Okay, you guys, today we are going to do a quick refresh on how to graph absolute value functions. What we're looking at on our practice problems today are transformed absolute value functions, but I actually want to start with the parent function. So if I just had y is the absolute value of x, what would that look like? I'm going to plot that on my first graph here. Remember, absolute value functions are V-shaped. Our key point, that corner, is at the origin, and the slopes of our sides are +1 and -1. So my absolute value graph looks like this. On each side from my corner, from my key point, I go out one and up one, 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 out one and up one. So again, I have this V-shaped graph. Way back last semester, I think in Unit 2, we looked at this using a table of values. And we said if we pick values for x and plug them in to our absolute value function to see what we get for y, the absolute value of -3 is 3, absolute value of -2 is 2, 1, 0, absolute value of 1 is 1, absolute value of 2 is 2, and so on and so on. And that's where these points are coming from. 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3, and so on. So this is our parent function, our parent absolute value function. Now what we can do with functions is change them, right? We can make changes to our function, and that results in changes in our graph. So again, last semester, we talked about transforming parent functions. We did this with absolute value functions. We did this with quadratic functions, square root functions, linear functions. Point slope form is just a transformation of our parent linear function. So we're going to do that here again with our absolute value functions, where I have a change made directly to x, in this case inside my absolute value bars. It could also be inside parentheses or under a square root, where I have a change made directly to x. That's going to move me left or right. In this case, since I have x plus 1, that is going to move our graph to the left 1 space. So every point on our graph will shift left 1 space. Anytime I make a change at the end of my function, not directly to x, but at the end, that's going to move me up or down. In this case, since we have -4 here, this will move me down 4 units. So I'm going to start by shifting my key point, moving my key point left 1 and down 1, 2, 3, 4. So my key point now lives here, right? Our parent graph was just for reference. This is where the graph of this function starts. And then I look at the front of the function to decide how I'll change the shape. Am I going to keep the size of my absolute value the same? Am I going to flip this? Am I going to stretch or compress? Since we see a negative here in front, that means our graph is going to flip. Okay? It's going to flip over that horizontal axis. So instead of going out and up, we'll go out and down. So that's what I'll do here. Out 1, down 1, out 1, down 1, out 1, down 1. Same thing on the other side. Out and down, out and down, out and down. And there is my transformed graph. Now for the rest of these, I'm not going to plot the parent function first, but since we have it on number 1, we can refer back to it if we need it. I'm going to scoot over here to number 3. Same idea. I know I'm going to have this V-shaped graph, but I know it's going to be transformed because of the changes I've made to my function. So I'm going to start again with where does that key point live? Since I've got x plus 3 here, that means that we will go to the left 3 spaces. -5 at the end means we will go down 5 spaces. So that key point is normally at the origin. Let's go left 3, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. Now I look at the front of my function to decide what the shape of my graph will be. Is it going to be the same as the parent function or transformed? This value in front is negative, so I know that we're going to flip this graph because of the negative. And because of the 2, I know we're going to change that steepness of the sides. We're going to change the slope of the sides. Since this is a number greater than 1, we're going to be stretching by a factor of 2. That stretch, or if it were a number less than 1, that compression would mean that we're changing the vertical distance. So we still go out the same amount, still out 1, but we're going to change how far we go up or down in this case. So I'm going to go from my key point out 1, since we're stretched by 2, down 2. And on the other side, out 1, down 2, out 1, down 2, out 1, down 2. And there's my graph. Now, if this were, let's say, maybe a half in front, I would go out 1, down a half, out 1, down a half. And same idea. Next time, out 1, down a half, out 1, down a half. Let's take a look at number 2 now. Same idea. I'm going to start by looking at where that key point should be. I have x plus 1 here. That means we're moving to the left 1 space. Notice every time I've had x plus something, we're moving to the left. Okay. In the next one, we've got x minus. So we're going to move to the right. Here at the end of my function, we've got minus 5. So that's down 5. We've had minus, we've had subtraction at the end of all of these functions so far. Our last one is also a subtraction. If it were addition instead, we would move up. So key point from the origin, left 1, down 5. And now if I look at the front of my function, I don't see anything here. There's no negative, there's no number. That means we're going to keep the same shape as our parent graph. So for the side, out 1 and up 1 on either side. And I'm going to go a few points in either direction, just so I can get a good picture of the shape of my graph. One more to look at together. I've got x minus 5. This will move me to the right 5 units. And then minus 1 at the end will move me down 1 unit. So I'm going to go right 5 and down 1. And now if I look at the front of my function, I don't have anything there. So I'm going to keep the same shape as my parent graph. So out 1 and up 1 on either side, out 1 and up 1, out 1 and up 1. And again, just a few points on either side here. And then I can see my V-shaped absolute value graph. So as you're graphing these, remember we should have that V shape every time. Start by transforming your key point, that center of the V, shift that wherever it needs to go, up, down, left, right, and then look at the front of your function to determine if you need to make any other changes. Does it need to be flipped or stretched or compressed? And we do the same thing on both sides.